Hello everyone, welcome to the Gate Engineering online learning classes. In this video, we are going to solve some problems on the Laplace transform. This is the first part of the problems on the Laplace transform. In the next video, we will solve some more problems on the Laplace transform. So we are covering three problems in this video based on the properties of the Laplace transform. Okay, so let's we begin from the first problem. And all these problems are very helpful to solve the problem in the GATE exam. So first problem is that we have to find the response yt. We have to find the response by t for a causal LTI system that is given in this function hs, which is s plus 1 divided by s square plus 2s plus 2. And we have also given the input xt, which is e to power minus t ut. We have to compute yt, that is our response or output of the system hs. So first of all, to solve such kind of a problem, we should understand what is the relation between xt, hs, and yt. How we can relate. We have to compute y in time domain. We have given input in time domain, and we have given system in the frequency domain or s domain. So we have to plan accordingly. We can solve the problem. Let us consider this is our system hs. We have a system hs. So for that, input should be in the frequency domain only. Okay, so what we can do, we have given input x as output will be nothing but multiplication of both. Output or response will be xs into hs. And in other way, in time domain, or in another way, in time domain, if signal input is xt, system should be in time domain. System should be in time domain, then output is not in multiplication, but it is in convolution. So yt will be nothing but xt convolution of ht. xt convolution of ht. So these are the two relations. Now we have to plan which approach is correct for this problem. So we have a two relation. One is the output ys equal to xs hs, and second is the yt equal to xt convolution of ht. So from this expression we will get ys, and from this expression we will get yt. So what we can do? So in this is such kind of a problem. First, we need to take the inverse Laplace transform of hs to make ht. So that is the one possibility. Then we'll compute the convolution of xt and ht. Then we can get the yt. This is the one way to solve problem. And another way is that first you take the Laplace transform of xt, then you multiply both of them, then you take the inverse Laplace transform of ys. There are two ways to solve, but computing the multiplication compared to the convolution is easy. So we will use this first approach, that is nothing but ys equal to xs hs. And we know it's very easy to compute the Laplace transform e to power minus tut. It's very easy by the relation of Laplace transform of e to power minus at ut. Laplace transform e to power minus at u of t, that we know Laplace transform e to power minus at ut is nothing but 1 divided by s plus a, that we know. So in this given signal e to power minus tut, a is nothing but equal to 1. So in this signal, a is nothing but 1. So we can replace a as 1 here. So we'll get xs equal to 1 divided by s plus 1 for given input signal e to power minus tut. So now we have xs, we have hs. To get the ys, we multiply both of them. Then we will get 1 divided by s plus 1 into s plus 1 divided by s square plus 2s plus 2. And here this s plus 1 will cancel out by this s plus 1. And finally we will get 1 divided by s plus 1 whole square plus 1. Now here we will use some property. One is the frequency shifting property we will use, and one we will use the inverse Laplace transform of 1 divided by s square plus 1. So as we know, Laplace transform of sine t, as we know, this is the well-known Laplace transform of sine omega t, is nothing but omega divided by s square plus omega square. That we know. Okay, so here, if we consider omega is equal to 1, so we will get 1 divided by s square plus 1. We will get 1 divided by s square plus 1 here. So this ys will be 1 divided by s square plus 1, but here s is in shifting, so we can write shifting in the frequency domain is nothing but multiplication of e to the power minus at in time domain. So from this property, we are getting 1 is the e to the power minus at multiplication with y of t, or multiplication of sine t. So here 1 divided by s square plus 1 is our sine t. So in this problem, here a is equal to 1. So answer is e to the power minus t sine t ut. That is satisfying the option A. So option A is correct, e to the power minus t sine t ut for this problem. Now come to the second problem. In this problem, we have to compute the Laplace transform sine omega t plus alpha. Okay, so first we will see what is the Laplace transform of sine omega t and what is the time shifting property. So as we know, Laplace transform of sine omega t is omega divided by s square plus omega square. That is a well-known function, and we have also seen in the last question. And we will use another property, that is the Laplace transform of ft plus t naught. That is nothing but fs e to the power s t naught. Okay, if we combine both these property, what we will get, sine omega, we will get sine omega t plus t naught. If we combine both of them, sine omega t plus t naught. Then if we compute the Laplace transform of this function, by combining both of them, both of the above property, we can write it as omega divided by, because our fs is nothing but sine omega t here, and that is shifting by t naught. So we can write it as omega divided by s square plus omega square into e to the power s t naught. That we can write here. Okay, so if we use the same property for this function, what we can write this function? Sine, we can write it as, we can write this function as sine omega t plus alpha divided by omega. We can write like this. Okay, so here this is nothing but the same as it is. So what we can write, Laplace transform of this function will be omega divided by s square plus omega square e to the power s alpha divided by omega. So here we are using the same thing. We are writing sine omega t plus alpha as sine omega t plus alpha divided by omega. Here alpha divided by omega is nothing but t naught. So what we can write here, omega divided by s square plus omega square e to the power s t naught, that is nothing but alpha s divided by omega. So according to this answer, option B is correct. And other thing is that directly we can select the option by seeing this question. How we can see, how we can identify which is the correct option? If you know the Laplace transform of sine omega t, you can directly take the correct answer here, because Laplace transform of sine omega t is omega divided by s square plus omega square, that we know. And here only option B is matching with the omega divided by s square plus omega square. Out of all four the options, so option B is only correct option here. To the third problem, which is the Laplace transform of it is given as 2 divided by s into 1 plus s, and we have to compute the value of it at t tends to infinity. So this problem somehow related to the finite value theorem. We have a given is for it, and we have to compute the value of it at t tends to infinity. So we can solve this problem by very easy way by using the final value theorem. And we know the final value theorem is the limit t tends to infinity it, which is equal to limit s tends to 0 s is. So here, to computing the it at t tends to infinity, just we compute the s tends to 0 s is. So we substitute is here and we will get limit s tends to 0 s into 2s divided by 1 plus s, and this s will cancel out, and finally we will get 2, and finally we will get answer it equal to 2 for t tends to infinity. So this is the correct answer, which is a C here. This is the correct answer for this problem. Thank you for watching this video.